Now let's do this question, okay? For the given network, find the voltage Vx. So what is Vx? If you look over here, Vx is the voltage across this 11 ohm resistor, okay? So basically this problem has a dependent voltage source, right? There is a dependent voltage source, which means there's no other change. Simply do this problem. Just assume that all you need to do is express the equation of Vx, or write the equation of Vx. And let me mark the node voltages. So here we have basically we have this is V1. Let this node be V2, and let this node be V3, right? So V1, V2 and V3, okay? So here you can see, so now I can tell you what is Vx. What is the Vx? Vx is the voltage across the resistor, or voltage across a resistor. And what is the voltage across a resistor? You see, this is the higher potential, this is the lower potential, right? So which means the current is flowing from V2 to V3, right? It is flowing from left to right, from V2 to V3, which means the voltage across a resistor is V2 minus V3. That is Vx is equal to V2 minus V3. Vx is equal to V2 minus V3. That's all. That is the only thing. So now wherever you see Vx in your node equations, wherever you see Vx, simply substitute that Vx with V2 minus V3. The rest of the procedure is exactly the same. Okay. So here you can see that this is also a super node, because V1 and V2, in between V1 and V2 there is a voltage source called as 6 volt. Therefore V1 V2 is considered as a super node. So which means this entire branch is a single node, which means you need to mark the currents like this, over here, over here, over here, over here, and over here. You see, this is how you mark the currents, right? Because the current that is flowing out of V1 and the current that is flowing out of V2, because V1 and V2 is the super node. So how many currents are there? 1, 2, 3, 4, 5, which means there are 5 terms, right? So let's write this equation. That is equation for super node V1 dash V2, okay, or V1 V2. So equation for super node, which means I'm going to write the current through this branch. What is the current through this branch? It is V1 minus, or not only that, see, there is already a current over here. What is the name of the current? It is 2 amperes, and it is flowing in the opposite direction, or it is incoming, right? It is going into the junction. Therefore this is minus 2, okay? So the current, the first branch is minus 2. What about the current through this branch? It is V1 minus, this is, what is this? This resistor is connected to the negative battery. It is connected to the negative terminal of the battery. So it is V1 minus of 5. Or it is nothing but, this is nothing but V1 minus is connected to the negative terminal of the battery, right? So it is minus 5. V1 minus of minus 5 by 4. So this is basically V1 plus 5 by 4, okay? Then what else do you have? That's it. That's what these two currents. What now? Next will be these 3 currents, right? So first I write in terms of V2, and what is V2? Here this is, there is a voltage source called as 2Vx. So the voltage is, so the current is V2 minus 2Vx by 10. So plus V2 minus 2Vx by 10. V2 minus 2Vx by 10. Okay. So that is it. And next will be the current through this branch, and the current through this branch is V2 minus V3 by 11 plus V2 minus V3 by 11. There you have it. And then the current through this branch, right? That is going to be a little bit tricky. See over here, the current through this branch. What are the different voltage source in this branch? Here there is a V2, here there is an 8 volt, and here it is V3, right? So how do you write the equation for this branch? We have already did like this kind of a problem in the previous section. That is, here you can see the current is flowing from V2 to V3, right? That is, V2 is the higher potential and V3 is the lower potential. So therefore V2 is positive and V3 is negative. That is V2 minus V3, right? But what about this 8 volt? Is it plus 8 volt or minus 8 volt? Look at the direction of the current. This current is flowing like this. it is flowing into the positive terminal, which means this positive terminal is not generating current, it is opposing current. So therefore the voltage across the 7 ohm is, the voltage across the 7 ohm is V2 minus 8 minus V3. See, this is the voltage across the 7 ohm. So the current across the 7 ohm is V2 minus 8 minus V3 by 7. That's it. See, this is the equation. This is the current through this branch. That's flowing from V2 across the 7 ohm across the 8 volt to the V3. That is the current through this branch. Okay, that's it, right? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. 5 terms. So this is equal to 0. I will write over here. This entire equation is equal to 0. Right? So now I will just write this in terms of, first I will remove this Vx, right? What is Vx? V2 minus V3. So I replace Vx with V2 minus V3. Let me write that equation. So it will become minus 2 plus, this is V1 plus 5 by 4. And this is plus, what about this? This is V2 minus 2Vx, or this is V2 minus 2V2 plus 2V3, right? V2 minus 2V2 plus, or this is nothing but minus V2 plus 2V3, right? Plus 2V3 by 10, right? Let me just do this calculation. Let me see. V2 minus V3. So minus 2 into V2 is minus 2V2, and minus 2 into V3 is plus 2V3. So minus 2V2 plus V2 is minus V2, and the remaining is plus 2V3 by 10, right? So plus, this is V2 minus V3 by 11, V3 by 11, plus this is V2 minus 8 minus V3 by 7 is equal to 0. Okay, so now I will separate V1, V2 and V3. So first I write in terms of V1. Okay, so V1 into, V1 is over here, and that is 1 by 4, and there's no other V1, only over here, right? So that is V1. And next I'll write in terms of V2. So what about V2? V2 is over here. This is minus 1 by 10, minus 1 by 10. Then there is V2 over here. This is plus 1 by 11, plus 1 by 11. Then there is V2 over here. This is plus 1 by 7, right? Plus 1 by 7, right? Only three places, right? Over here, and over here. That's it. Now next is I'm going to write in terms of V3. And what about V3? V3 is over here. This is minus 2 by 5. Minus 2 by 10. Minus 2 by 10 is minus 1 by 5. So it's minus 1 by 5. Okay. There's V3 over here. This is minus 1 by 11. Minus 1 by 11. There's V3 over here. That is minus 1 by 7. Minus 1 by 7. Right? That's it. So I have written all V1, V2, V3. Then what about the remaining terms? The constants. Here it is minus 2. So this side of the equation becomes plus 2. Here you have plus 5 by 4, which means it becomes minus 5 by 4. Okay. Here there's nothing. Here there's nothing. Here there's nothing. Yeah, here there is minus 8 by 7, which will become plus 8 by 7. There you have it. Okay. So this is the equation, correct? This is the equation. So now I can find the value. So what here, let me see. This is V1 into 1 by 4 is 0.25, right? And what about V2? This is plus V2 into, let me see. This is basically this is 0.1, right? Minus 1 by 10 is 0. So minus 0.1 plus 11 inverse plus 11 inverse plus 1 by 7 or plus 7 inverse is equal to 0.134. So V2 into 0.134. That's the story of V2. What about this V3? Here you have is all are minus, right? So anyway, you write minus 5 inverse, minus 11 inverse, and minus 7 inverse. Let me see. Minus 1 by 5, minus 1 by 11, minus 1 by 7, and you have is minus 0.434. This is plus V3 into minus 0.434. 0.034. Okay. Here V3 is 2 by 10. It's not plus 2 by 10, right? It is this is plus 2 by 10. So which means this is plus 5. You made a mistake over here. This is plus 1 by 5 over here, right? It's plus 1 by 5. See, you have plus 2 V3 by 10, right? So if just plus 2 V3 by 10, it becomes 2 by 10, which is nothing but it's 1 by 5. This is correct, right? It's 1 by 5. That's why it's looking. So which means this is, remove this minus sign over here. That's it. So you have is minus 0.034. Minus 0.034. The reason why I was able to find this mistake is because before doing this video, I have already worked out the same problem before. See, that is how I become perfect in this problem. I try to do this by practice. That is what I always tell to all my students. Before doing this problem, always it's good that you always practice this problem. See, right now I know all of you are watching this video. Right now I want you all to don't write the notes now. Okay, don't write the notes. Simply watch the video, and then after that you just close the video. Okay, close the video and then do the same problem by yourself without any help and see if you get the right answer. Okay, that is the best way of learning. Either you, like I said before in the previous videos, either you pause the video before when I'm writing the answer, before when I'm beginning to do this problem, you pause the video, copy the question and try to do the problem by yourself. And if you still want to learn, if you're still having some doubts or some confusion anywhere, so what you need to do is just watch this video from top to the end, from start to finish. Watch the full video, then you close the video and then you do this problem again by yourself. Okay, so this is where did I stop again? So I have reached till here, right? This is minus 0.034 and this is equal to, what about this? This is 2 minus 5 divided by 4, 2 minus 5 divided by 4 plus this is 8 divided by 7, right? And you get over here is 53 by 20, which is 1.893. This is 1.893. Okay, 1.893. So that's one problem we did. So this is one equation. So supernode means is one more equation, right? There's an equation for the 6 volt, right? So what is the 6 volt? This is positive terminal. The 6 volt positive terminal is over here and the negative terminal is over here, which means it is V1 minus V2 is equal to 6. V1 minus V2 is equal to 6. That is the voltage of the, what is the equation for this voltage source? Okay, so right, so I like that I found this equation. Now I'm going to write the node equation for V3, right? So equation for node V3. Equation for node V3. Equation for node V3. Let me see. V3, there are 3 branches, 1, 2 and 3. 3 branches, right? So what is the equation for this branch? Here there is already a current called as 12 amperes, which means the current through this branch is 12 amperes and it is plus 12 because it's going in the same direction as your assumed direction, or in other words this current is also outgoing, right? So this is plus 12. So we have 12 plus, what is the current through this branch? It is V3 minus V2 by 11, right? V3 minus V2 by 11. V3 minus V2 by 11. And what is the current through this branch? So you can see in this branch there is V3, there is 8 volt and there is V2, right? So since this current is flowing like this, V3 is the higher potential and V2 is the lower potential, which means V3 is positive and V2 is negative, which means there is V3 and minus V2. Now what about this 8 volt? Is it plus 8 or minus 8? Let's look at the direction of the current. This current is going like this, right? It's flowing from V3 to V2, which means this current is flowing out of the positive terminal, or in other words this positive terminal is generating current, which means this 8 volt is positive, which means the voltage across a 7 ohm is V3 plus 8 minus V2. So this is plus V3 plus 8 minus V2 by 7. That is the current through the 7 ohm resistor. Okay, that's it, right? 1, 2, 3, only 3 terms. So these are the 3 terms. This is equal to 0. So which means now I can write in terms of V2 and V3. So in terms of V2, I will write first, this is V2 into, this is minus 1 by 11 over here, and here you have minus 1 by 7 over here. Okay, that's it, right? Only these 2 terms. And plus, and what about V3? V3, there is 1 by 11 over here, and there's 1 by 7 over here. Okay, that's the story of V3, and that's it, no? So what are the remaining terms we have here is minus 12, and here you have is minus 8 by 7. Minus 12 and minus 8 by 7. That's it, right? Let me see. So what is 11 inverse plus 7 inverse? 11 inverse plus 7 inverse is 0.234. So this is basically minus 0.2234 V2, and this is basically plus 0.234 V3 is equal to, what about this? This is minus 12 minus 8 by 7. 8 divided by 7. Minus 12 minus 8 by 7, and you get is minus 13.143. Minus 13.143. There you have it. Okay, so let me write those all the equations. So what is the first equation you have is this equation right here, right? What is this? This is 0.25 V1, 0.25 V1 plus 0.134 V2 plus 0.134 V2 plus minus 0.034 V3 minus 0.034 V3 is equal to 1.893 is equal to 1.893. Okay, and the other equation is V1 minus V2 is equal to 6. That's the other equation. That is V1 minus V2 is equal to 6. That's the other equation. And the third equation is minus 0.234 V2 plus 0.234 V3 is equal to minus 13.143. Okay, let me solve it using a calculator so I don't have to waste much time, right? So if here, let me see where's the equation method. What I just saw it somewhere. Yeah, this one. This is the equation 1. And how many unknowns are there? There are 3 unknowns, right? So 3 unknowns. So I need to write all the 3 unknowns equations, right? Okay. So first one is 0.25. Second one is 0.134. The other one is minus 0.034. Then you have is 1.893. 1.893. Okay. Now second equation, we have V1 is 1, V2 is minus 2, sorry minus 1, V3, there's no V3 over here, so V3 is 0, okay, and it's equal to 6. Here there is no V1 over here, right? So V1 is 0, V2 is minus 0.234, and we have V3 as 0.234, and we have is equal to minus 13.143. There you have it. Let's hope the answer is correct. We have V1 is equal to 1.667. Let me write it. Let me see if I get the answer. V1 is equal to 1.667. V2 is equal to 4.333. V2 is equal to minus 4.333 volt. Okay, and V3 is equal to minus 60.5, minus 60.5 volt. Right, let me check the answer. Yeah, okay. Yeah, this is okay. Yeah. So this is the answer, V1, V2 and V3. Okay, so what was the question, by the way? I forgot that. The question was find the voltage Vx, right? So Vx is equal to V2 minus V3, right? So therefore Vx is equal to V2 minus V3, which is equal to V2 is minus 4.333 minus, and V3 is minus of minus, right? Minus of minus 60.5 is equal to, so this is nothing but minus 4.333 plus 60.5, right? Plus 60.5. So we have is So we have is 60.5 minus 4.333, and you get the answer as 56.167. So therefore Vx is equal to 56.167 volt. This is the answer. Okay. Now I want you, like I said before, I want all of you to stop this video and then try to do the same problem by yourself. Okay.